Consider the following problem. Consider the following charges that attach by strings below. Calculate tensions T1 and T2 between the charges. Alright, in order to basically get this problem, let's draw a force diagram for each one of these particular charges. Right? Let's label these charges first. This is charge number 1, charge number 2, and charge number 3. Okay, so what are the forces here, right? Well, there's some electric forces here. I'll call this Fe, right? And that will come from basically 2 and 3, right? Plus the tension, right? This is the net force. And I'm assuming that the net force here is going to give me something that's 0. It's not accelerating, right? So in order to calculate the tension, T1, here, I need to calculate the electrical forces on 1 here as on 1. Similarly, for charge 3, if I'm going to get T2, right, let's again write the sum of the forces. All right, it's just going to be the electric forces, plus the tension forces, right? And again, this is F net. And of course, presumably this thing's not accelerating. So again, this is 0, right? So in order to get basic tension T2, I have to calculate what the electrical forces are on charge 3. Now, you might wonder why not just do it on charge 2. Well, the reason why you want to do it on charge 2 is that the sum of the forces here is just F electric, which will come from basically 1 and 3, plus the tension from T2, plus the tension from T1. All right? Okay, just a little more complicated. You can do it, but it's just a little more complicated. All right, so the way we get these tensions is we're going to basically calculate the forces on number 1 and number 3. All right, so let's start. Okay, so the electrical forces here, let's call this E. Well, what are they? They're going to be the force from 2 on 1 plus the force on 3 on 1. Okay, well, let's just see what this thing is going to be in the first place. So F21, that's Coulomb's constant, Q2, Q1 over some distance R21 squared, R21 hat, that's the first one, plus the Coulomb's constant, Q3, Q1 divided by R31 squared, R31 hat. Okay, so let's draw the vectors here. This one is R21 vector, and this entire vector is R31. Okay, right? Now let's endow this with a coordinate system because it's one dimension. I'm calling this the positive x direction. And so these two unit vectors here, as discussed in the first example, is just minus x hat. Right? Okay. Now the only thing we have left to do is to figure out what R21 and R31 is. Well, R21 is the distance between this charge, and that is basically d. So this is just going to be d squared. And this one is the entire distance, right? It's from here all the way here. So in fact, that is actually 2d squared. Okay, so let's just put everything together now. So basically for number 1, F electric is going to be equal to F21 plus F31 vector is going to be K. Now let's see, 2 is going to be plus Q. Okay, Q1 is going to be plus Q again, divided by, this is d squared in the minus x hat direction, plus this is going to be again Coulomb's constant again. Q3 is plus 2Q. Q1 is Q again, plus Q, if you want to do it pedantically, divided by, now this is going to be 2d squared, that's 4d squared. Okay, again in the minus x hat direction, right? So if you want to put this all together, right, k q squared over d squared. Okay, this is going to be 2 over 1 half, so it's going to be basically minus x hat, okay, minus, this is a 1 half here, 1 half x hat, right? So the final answer is 3/2 k q squared over d squared in the x hat direction. Don't forget your sign, minus sign. Okay, perfect. All right. So that is the electric field. You'll notice that this electric field is pointing in this direction. And so the tension, again, because the pulse is in that direction, so tension 1 is just going to be the positive value of that, or basically 3/2 kq squared over d squared. Okay, just to make sure everything's in the right direction. All right, so now let's do number 3 to calculate T2. Okay, now to calculate T2, again, we have to calculate the electric field on the electrical force on number 3. So that electrical force is going to be equal to F, okay, the force on 1 on 3 plus the force on 2 on 3. Okay, now this one, surprisingly enough, is something you just calculated. In fact, this force F13 is just basically the minus sign of F31. So this is going to be equal to minus F31, right, plus F23. Okay, so let's just write down what F31 is. It's just going to be this bad boy right here, K 2Q over Q divided by, remember, it's 2D squared, 4D squared, perfect. And the only thing is there's a minus here, and then there's a minus x hat. All right, so the minus minus gives you a positive value. So basically this force is in the positive x direction, whereas F31 was in the minus x direction. Right, this is just basically Newton's third law. Every action has an equal opposite reaction, right? But they're just on different objects. So this was the action, this was the reaction, right? And the reaction is basically the minus of the acting force. Okay, so let's basically do this second part, plus K Q2 Q3 divided by R23 squared R23 hat. Okay, so what is R23? Well, R23 goes from point 2 all the way to 3. That's R23, okay, vector. And R23 hat is just pointing along the x direction. So this thing is just x hat, very simply, right? And what is R23 without the vector? That's the distance. That distance is just d. So this thing is just going to be d squared, right? So let's put this all together now. This is going to be equal to minus a minus is a positive. So k 2q squared over 4d squared, perfect, the x hat direction, plus this one is going to be k, q2 is going to be a plus q, q3 is going to be again a plus 2q divided by d squared, okay, in the x hat direction. And so we plug this is a 1/2, this is a 2, this is going to be a 5/2, so 5 over 2 k q squared over d squared in the x hat direction. And so that completes number 2. All right, I hope that was helpful. Just got to break down the problem into its constituent parts, and then you're done.